Okay, so next topic is something that we kind of touched on very briefly in the last set of lectures, coercion, and then we'll also talk a little bit about truthiness. If you think about computers, right, at the end of the day, like everyone I think is pretty familiar with the idea that computers are written in zeros and ones, right? It's either something or it's not. Like there's only two conditions, and really that's like a very kind of powerful idea in not just like binary, but also like in non-binary like machine language, but also just in like how coding works, right? In most cases, computers are very good at choosing A or B. They're not great at choosing between like five different things with a lot of nuance, right? Computers need to be very, very detailed and very precise. And so when you give it commands, it also needs to be equally detailed or precise. And the most clean command you can give a computer is just, hey, there's two conditions. You either do it or you don't, right? There's no ambiguity there. And so a lot of what we're talking about in this section here is around this idea of coercion and also coercing into a boolean specifically. This we also call truthiness because when you convert something to a boolean, there's only two conditions. It's either true or it's false, right? Or it converts to true, hence truthiness, or it converts to false, which we also call falsiness. But yeah, so explicit coercion is something that I think I'm not going to necessarily talk too much about because I think it's very straightforward. Explicit conversion is I have a variable, right? And here in this case for num, it's a 10. It's clearly a number type, right? If I then say, hey, convert it into a string, and then print it out, I now get a string, right? Explicit means I am very, very clearly saying this, like change this thing into this thing. Like I tell you that this is a number, and I say here, make this into a string for me, right? Explicit. We tell the reader exactly what we're changing this from something that's type A to something that's type B. Okay, very straightforward. You'll see this in code somewhat, but the reason why I'm going to move on from this is just because it's very clear like that's what's happening. However, the reason why we talk about explicit coercion is because here we're actually telling someone what this is becoming, right? Where in this case we're saying, hey, we start off with something called with a string, and eventually we make it into a number, right? And once again, it's explicit because we're casting it as a number, we're saying, hey, take this thing, this variable here, and make it into a number type. Implicit coercion then is the opposite of that, which means that we are still changing something from one type to another type, but we're not actually exactly telling you what it is. We kind of we basically let the code and we let JavaScript kind of dictate what it transforms into. And so this is a very common pattern that you'll see, and it's something that's very easy to get hung up on because once again, when you read through the code, there's nothing that says I'm changing this from A to B, but in fact, that's what's happening behind the scenes. So let's take this for example. If I say, let sum equals the number 10 plus the number 20, what do you think sum is? 30. Wasn't your question. 10 plus 20, 30. Numbers, right? Math. Cool. Basics. All right? And let's say I have something, as it indicates, it's called concatenated string. It's the string 10 plus the string 20. What do you think this is going to give me, assuming I print this out? And what type is that? String, right? It's going to be a string, and that will have the characters 1, 0, 2, 0, right? Number, simple math addition. String, like we're just shoving two strings together, right? In both these cases, it's pretty clear what's happening. There's not much ambiguity there. But then when I do something like this, I have the number 10, and I add it to the string with the characters 2, 0. Now what does this give me? An ant?
An AN? Not a number?
Oh, not a number. All right, not a number. Okay.
Well, because you're adding a string and not a number, so it doesn't know.
Yep.
It'll turn to a string, right?
Okay, so we have not a number. We have a string. 30 in the back. All right, how many people vote for 30? Okay, 5, 4 and a half, 5, 5. Okay, 5. All right, who votes for not a number? Not Dan, I guess.
No, sure you got it.
Okay, who votes for a string? All right, 5. Okay, so we'll just assume that. For the rest of you who didn't vote, what do you think the answer is? Yeah. Okay, so this is what we call implicit coercion, right? Like I have one type, I have another type. I'm doing something with it, and this is going to give me something. I just don't know what that is, right? And so I'm changing a type, but it's just not clear what I'm changing the type to. So if we were to actually test this out, the first one, yay, we have 30. Math, makes sense. Second one, we have the string 1020, makes sense. It's a string. Third one, this is also a string 1020. And the reason why is because whenever we add a number to a string, what JavaScript does behind the scenes says, well, in this case, when I'm adding a number and a string, I'm just going to make both of them strings and then add them together, right? And so these are kind of like the hidden parts of JavaScript where over time you need to kind of just more develop like an intuition for, right? Like when you look at this, if you're not sure, this is super easy to test out, right? But what you don't want to do is just say, oh, I really hope to God this converts both into a number and add them up, because if it doesn't, I'm really screwed. It's like, well, you will probably be screwed afterwards, because like that's how JavaScript does, right? So another kind of thing is that like in JavaScript, super easy for you to test out anything you don't know, right? You can write a one-liner that says console.log out 10 plus a string 20 and see what you get. But don't ever just avoid this and kind of hope that it will give you something else. So this is just kind of one rule that you will see, and this is probably the main one that we'll kind of like use in terms of kind of trickiness, is this idea that like the plus sign, when you're adding two numbers, it treats it as math. When you're adding it as two strings, it will treat it as kind of shoving two words together. When you treat it between a number and a string, it would treat it as converting both things to a string and then shoving it together. So same idea here, right? We have this thing. Yeah, we have one string and 4 real numbers. JavaScript says, hey, you're using plus, there's a string here. Everything else is going to be a string. So when we print this out, we just get that massive string there. Cool. So implicit coercion, right? Nowhere do we actually say, hey, you're all going to become strings. But that's what's going to happen anyway under the hood. Yeah. Somebody courses from number to a string if you try to add it. Okay, so with this one, this is something that's like probably a little bit trickier. But if you look at it, I guess I kind of gave away the answer here. But do you understand what's happening here?
So because the string is at the end of the statement, it actually functions mathematically for the first 4 numbers and adds them up, and then adds the string at the end, as opposed to when you had the string at the beginning.
Right.
It treated everything as a string.
Right. So there's a few like nuances here of how like JavaScript tends to read code, right? So when JavaScript, I mean, there's a lot of nuances how JavaScript reads code, but what we're looking at here really is this like notion that that there's an equal sign here, right? So on the left-hand side, I have a variable. On the right-hand side, I have a value. And whenever the JavaScript sees this, the first thing it does is says, okay, let's figure out what the right-hand side is first, right? So now JavaScript says, okay, let's figure out what everything in between these two things are. And when it does that, how does it recode? From what direction to what direction? It reads it from right to left, right? Or no, sorry, left to right. Sorry, left to right. Okay, it reads it from left to right. So what it's doing is that it's actually going through this and reading, say, it's going to read 10 plus 20. What does that give me? And whatever that output, yes, it gives us 30. But then it gives whatever that output is, it adds it to the next thing, right? And whatever that output is, it gives it to the next thing. And whatever that output is, it gives it to the next thing, right? So up until we get to here, this is just all pure math. And the computer's like really comfortable with it, right? I'm adding numbers to numbers. There's no ambiguity here. But then finally, when the final output of here says, great, I'm now at 100, then it starts to do, okay, what's the number 100 plus the string 550? Well, it doesn't matter what the number is anymore. The number is now going to become a string. So we're going to shove it together, and that's how we get this, right? So this is kind of shows also kind of another like kind of hidden nuance in JavaScript, which is that like you read like when you read this line of code, you also need to think about the way that the computer is like in what order the computer is processing all of this, right? In the previous example. In the previous example, the computer, once again, starts left to right, right? The first thing it says is, what's all of this? Well, it's a string plus a number, so they're both strings. Great, give me back a string. All right, let's do the next thing. What are we doing? We're adding a number to it. Well, it's a string plus a number, so they're both strings, right? And so on and so forth, which is why in the end result, we get this massive string, right? Because we start off as a string, every operation that happens afterward is going to give us back a string. You can think of it this as almost like a mini operation that returns a string, and then we add something else to it that's going to return a string. That's going to return a string, and so on and so forth. Here, we return a number, return a number, return a number, return a number, and then lastly, we return a string, which is why we get this 10050 thing. Everyone good up to this point?
There's no point where that string would be like in the middle, like around 30 or 40. No.
It could very possibly be in the middle, but then let's say this 30 was a string, right? Instead of this 50, and this 50 with a number instead. 10 plus 20 is still math. It's still going to be 30, right? And then 30 is going to plus 30, and what's that going to give me?
Oh, 60.
Well, the second 30 is going to be a string.
Oh.
It will be what?
30 plus. So 30 string 30?
No. It'll be a string with the characters 3030,
yeah.
Right? And everything added to it afterwards will become a string. So it'll be 3030, 4050, right? So if you put yourself in the computer shoes and you work from left to right, at some point you're going to change yourself from a number to a string, and then everything after you is going to become a string, right? You just got to do it in the right operation. Cool. Okay, so implicit coercion changes the types maybe without being super clear on what it's changing it to. One thing that you also see a lot of in JavaScript is also comparison, right? Because we want to know if two things are inherently equal to each other. And the reason why is, and actually I'll talk about this first, and then we'll talk about why we actually shouldn't use this. So when you're doing most I think kind of like starting off with JavaScript, most books tell you to use the 3 equal signs, right, as like the way to compare whether or not two things are equal. And the reason for that is because there's several kind of definitions of what equal is, right? So in the first line here, if I have two numbers and they're both 10, well, they're clearly equal, right? They're both two numerical values and they're both 10. Cool. People are very comfortable with that. In the second variation, you have the number 10, and you have the string with the characters 1, 0. And if we use 2 equal signs, which is also a valid JavaScript operator, the 2 equal sign will also say that's equal. And I think most people look at that, and at a high level, they're like, okay, yeah, you eventually, they're both become number 10, or we can both convert them both to string 10, and they're equal. And it makes sense, right? But then as we go down these different comparisons, we'll see that, for example, this string, true, it doesn't equal this boolean true. And this empty string here, it's equal to false. And the true is equal to the string called 1. And pretty quickly, it kind of like breaks down. And so the reason why this is all happening, and the reason why we strongly encourage folks to use a triple equal sign, is because when the triple equal signs, when it compares two things, it compares two parts of it. It compares both the type and the value. When you use 2 equal signs, what it does is it's behind the scenes trying to convert both things to the same type first, and then compare the value. The tricky part about the 2 equal sign part is that when it tries to convert both things to the same type, it's not always clear what type is being converted to, right? So if when we look at line 5 here, and the number 10 is equal to the string 10, do you know if it's converting both to a number first and then comparing it, or converting both to a string first and then comparing it? I mean, the short answer is like we don't know, right? Like we look at it, and yes, there is a way to find out. There's actually this very nice table that will tell you exactly what these things converted to. But at the end of the day, the takeaway from this slide for you really should be that just because two things kind of look equal in a human sense, when JavaScript, when we talk about comparisons, we always want to be as specific as possible. Remember, computers do very poorly with ambiguity, right? They're great at precision. So when we think about comparisons, we use the 3 equal sign to make sure that the two things we're comparing, they're both of the same data type, and they also have the same data value. So it is for this reason that, and we probably shouldn't have started off with this, right? But and this is for this reason, like especially kind of when you're starting off, you should almost never use the double equal sign. Everything should always be a triple equal sign. And guess what? If you ever have a situation where you want to compare this thing and this thing, and you want to check to see if, hey, if I convert this to a number, if I convert this to a string, are these two still equal? You do it via explicit coercion, right? You say, I'll make the first thing a number, I'll make the second thing a number, and then I'll do a triple equals compare on them, right? Because at this stage, like what we really want to do when we do these comparisons is just be very, very clear about what we're comparing. And comparing something that's the same type and the same value is always going to be kind of like the final end all be all of making sure two things are exactly equal. Oh, sorry. Okay. Oh, sorry. This is. Okay. Any questions on double equals versus triple equals? The short rule of hand is just always use triple equals, but I just want to give you guys a bit more context around why double equals is a lot more dangerous, because you do a bunch of implicit type conversions in the back end that the user doesn't really see. Okay. Okay, so now that we've talked about coercion, right? The last form of coercion then is trying to coerce something into a boolean, right? Remember how I was talking about in the conditional for the while loops, and also in the comparisons for the for loops, right? In both cases, what I told you was, yeah, you can have a really fancy operation in there, but at the end of the day, what JavaScript really cares about is, hey, is this true or is this false? If it's true, I'll run my loop. If it's false, I'm going to stop running my loop, right? That's all it does. And so when we talk about coercing to Boolean values, it's that same idea. It's like, hey, I don't care what you give me. I'll do all the computation, all the operations you want me to. But at the end of the day, you just got to tell me, is this true or is it false? And so because we're converting something to something that has one of two possible states, well, in JavaScript, there's this really convenient data type called a Boolean that only has two possible states, true or false. So that's why when we talk about truthiness, falsiness, it's basically kind of the idea is that we're basically converting something into a Boolean, something that has one of two possible states, true or false. Okay, well, so here, these slides, I'll go through them fairly quickly because there are a lot of are things I think you will probably be better served looking at home kind of at your own pace on. I don't want to spend too much class time on them, right? But just a few things to know, right? Most things, it's actually, when you talk about like, if I give you a value, is this true or is this false? It's actually a lot easier to remember what the false are, and then everything else is going to, by definition, be true. Okay? So for example, if I have a string here, and I try to convert it into a Boolean, the answer is this is actually going to be true. Because guess what? All strings are true except for empty strings, right? So in that case, anytime you see a string, even if the string says false or like whatever, doesn't matter, right? As long as the string has at least one character inside of it, it's going to be true. Otherwise, it's going to be false. So things that when we convert into a Boolean, if they eventually are converted into a true in Boolean, they're called truthy or truth-like, and then similarly for falsy or false-like. So here we're just going to give you a bunch of examples that are truthy, which, yeah, all arrays are truthy, all objects are truthy. And then these are the list of false values in JavaScript, right? So we have an empty string, we have the number 0, nulls, undefined, and not a numbers. Those are the falsy values in JavaScript. Everything else. And then, of course, we didn't put it here, but obviously false is also a falsy value. So those are the only JavaScript values that if I convert it into a Boolean, it will be false. Everything else is going to give me true. Everyone cool with that? Pretty easy to swallow, metaphorically speaking. Yeah, Francisco?
So you said like let new bool equal Boolean I am a string. Is the Boolean function like a function in all JavaScript libraries?
Yep. Yeah, that is a data type in JavaScript, and whatever you pass into it, JavaScript will say, okay, where you give me, you were asking me to make it to a Boolean. So really what it's saying is it one of these 5 things? Because if it's not, I'm going to give you true. If it is, I'm going to give you back false. and I give you back a Boolean data type. So then if we kind of extrapolate that one step further now, right? Once again, we go back to our loops, right? These conditionals. Now you understand how these kind of work, right? Like these things inside the conditionals, it's going to evaluate into a value, right? Whether it be a number or a string or something else. Whatever's in these parentheses, in this conditional, it's going to be evaluated into a number. And then JavaScript basically, without us seeing it, JavaScript essentially is going to say, hey, let's convert this thing into a Boolean. If it's true, then in this case, I'll do whatever's in the if clause. If it's false, I'll do whatever's in the else clause, right? So the reason why this section is here is because if you really think about it, for these conditionals in these loops, JavaScript is once again doing an implicit coercion for us of whatever it is that we're evaluating into a Boolean. So once again, we're kind of changing data types, if you will. And so this example kind of, hopefully drives the point a little more home, right? I give you a string. Well, that's not really nothing to evaluate. It's just a string. Well, yeah, but if I shove that value into a Boolean and ask a Boolean, if I say, hey, Boolean, you have to really give me back, a true or false value, a Boolean's going to say, well, in this case, you have a string. It has characters in it. Therefore, it must be what? Therefore, it must be true. So therefore, what's going to run? The if clause or the if clause or the else clause? The if clause. I mean, these are just more examples of the same idea here. If I give you a number, convert into, in this case, it's going to be true or false. True, right? It's a real number. It's a number that's not 0. So therefore, by definition, it's going to have to be true. And then obviously, if it is 0, then we're going to get false, or in this case, no. Okay. Any questions there on the way that that JavaScript does these coercions for us behind the scenes, implicit coercions?
All these slides are posted.
These slides are all in your. I'll actually walk you through after this how to get to these slides. It's cool. A little bit counterintuitive, but.
If they have questions, it's not stuff
Yeah, some of these stuff you want to look at the slides a little bit more, just like like. This is one of the few parts in JavaScript where I do think like it might behoove you just memorize kind of roughly what are falsy values. Like I almost always tell people like don't spend your time memorizing stuff because ultimately like nowadays you're almost never gonna be programming in an environment where you're not gonna have access to internet. So like most of the charts of conversions of these rules like they're all online, right? So feel free to look up documentation. But this is one of those things where just to make it more convenient, memorizing it probably would help you be a little bit faster. Okay, cool. This last thing is something that this is going to be like one of the hallmark things where I explain, you nod, you do it, and it doesn't make sense. So I'll do my best to minimize the pain as much as possible. This exclamation mark, or what they call the bang operator. What the bang operator does is it basically just says, what's the opposite of the thing that it currently is, right? So if I have a string, is that true? Or if I have a string with like characters inside of it, is that true or false? True. So then the bang, if I put the exclamation mark, if I put the bang in front of the string, what would it be now? Great. See, it makes sense to you right now. And that's what I'm saying. Like it's gonna make sense now, but when we try to use it, it's gonna be really, really confusing. So the bang basically just takes the opposite of what something is and gives you back the Boolean, or rather, think of it this way: it takes if you convert what you have into a Boolean, the bang gives you the opposite of that, right? So if we have converts to a true, a bang will give you false. Conversely, if we have is going to be a false, the bang of that value is going to give you a true, right? So the bang, whatever, is always going to give you back a Boolean. It's just the opposite of what your original thing was. So all these things hopefully are going to be clear, right? These are all true or false, all these 5 things. Right, they're all false now because their original values were all true. And then the other one, and this is the one I think starts confusing, is sometimes if I have like a string, right, and it has my name, say a string of David, right, and I want to convert it into a true. I could cast it into a boolean, or I could say, all right, if I know that my original thing is truthy, and I put a bang in front of me, it's going to give me back a boolean value of false. What's the opposite value of false? So how do I get to true if I have a false? I put another bang in front of it. And so whenever you see these two bangs or the double bangs, like what this does is it basically gives you back the Boolean version of whatever this value is, right? So the Boolean value of a string with ABC in it is what? It's true. The original thing is truthy, so therefore the double bang value of it is true. 100 is truthy, so the double bang value. So the single bang value of it false, so the double bang value of it is true, right? This, once again, these double bangs, they do a pseudo, I guess, I don't know if it's implicit or explicit, but it basically converts it into a Boolean for you, right? So this is another way to convert things into a Boolean. People like this because it's very shorthand. It's you type in two things instead of casting it as a Boolean, like you did in our previous examples. Andrew.
So if you have a string and you put the double bang in front of it, from then on it'll just be, assuming there's letters in it, it'll just be true. It'll just be called true.
Yep.
Okay.
It will be a true Boolean value. It will be a value of Boolean type with the value true.
True. Okay. But it won't be the string anymore.
It won't be a string anymore. No.
Okay.
Well, sorry.
Like, will it still have the message that was originally in the string? Is what I mean.
Yeah. Well, so it depends. Like if you say like let x equals double bang the string, x is now going to equal to true.
Okay.
Because you're not changing the original string.
Oh, okay, I gotcha.
Right? So basically when you put a bang in front of a string or any value, it gives you back a new value, and it's up to you to store that value somewhere or use it in some way.
Okay.
In the conditional, JavaScript uses it for us right away. It says if it's true, I'll run this loop. If it's not, I'll run this loop. Otherwise, we need to store that value somewhere. Cool. So it doesn't, yeah. Okay, cool. So then lastly, we're kind of running on our last bit of operators here. Is we also have these things called logical operators. And they also do something very similar to us as well, right? So a lot of times, one common pattern you'll see in programming is we don't want to just check one thing, right? We want to check like several things sequentially. And really what we care about is, and usually kind of how we want to think about it is the two most common outcomes are we want to check to see if all of them are true or all of them are false, or like one of them is true or one of them is false, right? Yes, there are kind of intermediary use cases. They're less common. You can definitely do it this way, but for now, just think of it as like typically we care about if something is all true or if at least one of the things is true. And so the way to make that really easier is rather than writing a bunch of nested if statements, like if this is true and then if this is true and then if this is true, which just kind of takes you down this like cascading hell of bad code, right? We have these things called logical operators. For our purposes, there will be two logical operators. There's the and, so the double and, or the double pipe, the two vertical lines. With the and, well, so this in JavaScript, these two ampersands together are called and, A and D. And then the two pipes together are called or, right? And its name indicates whatever you chain together with an and, what you're telling JavaScript to do is make sure this is true, and this is true, and this is true, and this is true, right? So it's going to check, it's going to hopefully check everything for you in that list. And I'll talk about why it may not reach everything in that list. Similarly, if you just want to know if at least one of these objects is true, then you can what we can do is you can put like variable A or B or C or D. It'll just tell you, hey, is at least one of these things true? So a little bit confusing for now, but I'll walk you through kind of what the. So that's the and. We should get better at this. Okay. So then, in this if clause here, right, what we're trying to say is, hey, is 10 true, and is the 20 true? And in this case, what's the answer? true, right? 10 is true and 20 is true. So therefore, when we run this loop, this if clause is going to run. Both 10 and 20 are indeed truthy values. On the other hand, if I had this as my function, if 10 and 0, it's going to give me back what? It's going to give me back false, because what the false is going to represent is, hey, not everything you gave me is truthy, right? And in fact, one of them, the 0, is falsy. So therefore, when we run this, nothing else runs, but this, or rather the if clause won't run, but the else clause will. Cool. So the way that the AND operator works is it will give you back the first falsy value, or it will give you back the last value if everything you've evaluated is true. That's going to be a bit to digest kind of, as I'm talking to you. So when you get home, definitely look at this a little bit more, maybe draw it out if you want to kind of get a little bit more comfortable around it. But usually these logical operators are used. These logical operators tend to be used in these conditionals. So basically, like, despite what this may return, in this case, this is actually going to return 0, which this conditional is going to evaluate to be falsy. But in generally, you actually see the ands and ors being used in conditionals, right? So they're basically being used generally to be a Boolean, so either true or false. So then, in this case, we have something that's like 10 and apples and 0 and no. What is this going to return? Like, what is this statement going to evaluate to? No. Right? If I was to put this in a conditional and I convert it to a Boolean, it would be false. But what does this actually return? Or what's the value of return value 1? 0. Okay, so 0. Anyone else? Who thinks it's 0? 2. What does the other 21 of you think? False. A string? Good. Alright, I'm not going to make it too miserable. I'll just say that, let's just take this example too. So the second one, we have this as well. And then I think, so in the first one, we're going to have 0, right? Because what AND does is AND returns the first falsy value or the very last truthy value. In this case, or the last value if everything is truthy. In this case, we never got to the last value if everything is truthy because, halfway through, our third element is falsy. So we're going to give you back a false. Now, if we were to put this in a conditional, this would become false. Or this will return false, right? Because if I was to convert 0 into a Boolean, it will be false. Similarly, down here now, if I have these three things, first one's truthy, second one's truthy, and third one's truthy, and now we reach the end of it, JavaScript's going to say, okay, great, I'll just give you the last thing, right? Which is 7. And if I put that in a conditional and convert it to a Boolean, I get true. And so this is the part where if I were you, I would just worry less about. Typically, we use these and ors in context of a conditional. So we really care about, like, is everything in this true, or is at least one thing in this list true? And then these are just like kind of like more examples of kind of how OR works, right? So the two ands means we check things in sequence. The ORs is going to give you back either the first truthy value or the last value if everything is falsy. So in some ways, almost the exact opposite of the ands, right? So in this case, if this is a return value, we have nulls, undefined, and happies, and pumpkin. Well, really, what this is telling me, usually when I use this, what I want to know is, hey, at least one of these 4 things truthy, right? And so if it goes nulls, I know this is falsy, oh, this is truthy. Great, here you go. It won't even check the last one, right? There's no point to, because guess what? I already got at least one truthy thing, and that truthy thing is a string called happy. Similarly, down here, if everything is false, like this is false, this is null, which is falsy, this is a false statement, so it becomes falsy, and this is not a number, which is falsy. It's going to say, well, nothing in here was true, so just take the last false thing, and if you convert this into a Boolean, you will also get false as well. And that's pretty much it. And headache time.
Return value. That's a field in JavaScript.
Do you mean a reserved keyword?
Yeah, sorry. That's
No. Return is a keyword. RETURN.
yeah. I'm just
This is just straight up a variable name, like a random string that we made up ourselves.
I was just curious how it knew to only pull happy and not pumpkin or.
Yeah. Well,
Sorry, never mind.
yeah, because it goes from left to right, right? So
I'm trying to find where
false,
the logic
false,
is like.
truthy, and we're good. And we stop. Yeah. So we'll spend the rest of class today. I think we're running a little bit low on time, right? But the rest of the class today is going to be kind of spent on this idea of coercion, and on this idea of hey, sometimes we take things and we convert it into a boolean. Sometimes we convert it into a number. Sometimes we convert it into a string, and then sometimes in a conditional. Once again, we use it to convert it into a boolean. This section is going to be very like logic heavy, and so I strongly encourage if you want to like write things down, kind of go through it step by step. It's definitely one of those things where if you're just starting off and you're trying to think through it all in your head, it can probably cause you some headaches sooner rather than later. So yeah.